be good now, right? All right, so today we want to focus on functions. Is plenty little small notes, things you know already, one or two sets of terminology that may be new, right? But everything here should be familiar with, right? All right, so let's just start quickly with what we call a relation diagram. Right? So let's quickly take a look at a relation diagram. So it kind of relates, or it kind of gives a relationship between x and y values, right? So a function kind of gives us that relationship between x and y values. Let's say we have a few values here, 1, 2, 3, and 4, right? If we have those 4 values, and we're mapping them by a function x plus 1. Then, in order for us to map 0 to its corresponding value, we just add in 1 to it, right? 0 plus 1 is 1. 1 is called the image of 1 is called the image of 0, right? And then sometimes they like to access to the ordered pair. The ordered pair is 0, that's the x value, and the corresponding y value. Okay. Similarly, 1 will be mapped to 2, 2 will be mapped to 3, 3 to 4, 4 to 5. Right? What type of mapping we have here? Right? This is called a 1-to-1 mapping. Right? It's called a 1-to-1 mapping. Right? All these things you know already. Right? The ordered pairs 0, 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. Right? All those are examples of ordered pairs. Okay, same thing that quickly. Going back if you can go. You go for the particle. Okay, come on. All right. A few definitions that we need to learn about. Let's start with domain. Anybody remember what is domain? Set of x values. So in this case, our domain is 0, 1, 2, 3, 4. Definition. The domain is basically this consists of all the x values, right? Right? Then we follow here. Yeah, and just I want to show the definition in the part of the class, right? Codomain. Right, the codomain. This case is 1, 2, 3, 4, 5. Right? What's the codomain? Right? Codomain is the set of elements in which all the images are contained. And last one, I'll put this one a different color because it's the one that we tend to mix up was the range. In this case, the range is the same. In this case, the range is the same, and it consists of all the images. Right? All the images. I want to explain the difference between range and codomain, right? Copy it down. Take your time, copy it down. Right? So codomain is like where all the images come from. Okay? In this example, we can't differentiate between them because the codomain and the range is the same. You'll see that? But I'm going to show you an example where the codomain and the range is not the same. Okay? And then you'll understand what is the range and what is the codomain. All right. Again. No. Oh. This is what the credit is. This is what the credit is. Right. But she was saying about you was in the single class. Camera, allora si hai per di camera. What is disconnected? Yeah, the screen I recognize a guy trying to get it done. And they have the pump, so they do disconnect the computer. I need the water, there is more. Huh? Right. So sometimes, anybody writes it online? No, right? Okay. All right, what's your theory? Suppose I said that the function that we're using, suppose that the function we're using f of x is x squared, right? What was 0 be mapped to? What? What? Right? 0 will be mapped to 0, right? What will 1 be mapped to? 1. Well, 2 will be mapped to. Right. So let's see if we can find the domain. Let's see if we can find the codomain. And let's see if we can find the range. I'll let try it on your own first. And let's see if we can figure out the difference between each one. So see if we can figure out based on the definition some a little while ago. What's the codomain, what's the domain, and what's the range, right? Kevin, you paying attention? Hey, look at Zaria here, but make sure I think Zaria here right there. Huh? Right, so what do you all think the domain is here? 0, 1, 2. The domain is 0, 1, 2. Nice. All the x values, right? What do you think is the codomain? 0, 0, 1, 2. Now, based on the definition, the codomain is all values. Huh? Yeah, 0 straight to 4. The codomain is where you get the images from. So all the values. The values don't have to be an image to be the codomain. Okay? But for the range, the values have to be an image. So, what's the range? 0, 1, 4. 0, 1, 4. Okay? 0, 1, and 4. So here's an example of where the codomain and the range is not the same. You okay with that? Brittany?
Yes.
You okay with that? You sure?
Yes.
So the range must only have the images in them. Alright? The range must only have the images in them, right? Alright, so we have a domain, codomain, and range. Any questions online? Aaron, any questions? Safir? Alright, so that's just some definitions, right? Next, let's quickly take a look at the types of mappings.
One to many, the same thing, like in grade school,
Sorry?
like one to many, the range, the same definition, like the range school,
Oh, all definitions will change, same with definition, right? Anyway, I should you want the one already, yeah? Right, I'm not sure if you're seeing it clearly.
second one is the two, where they want to coverage.
Huh?
The second
The
one.
second one is 2 going to the one on top here. And the third one was the first one going to 2 and so on, right? Let's see if we can name the types of mappings, right? Second one, no. First two go into the top one, and the last one go into the second. It don't matter, we change that. And we change that. Right, Steve, remember the label. Ready? So first one, if you look at the first one, there's one value in the domain going to two values in the range. You all see that? So that's one to many. So the first one is one to many. So once you have one value in the domain with more than one mapping in the codomain, that is your one to many. Second one is what? Right? Because they have many x values going to one y value. So this one here is many to one. And the last one is all over the place. The last one you have 1x to 2y and 1y back to 2x and so on. You'll see that? So that's a mixture, right? So that's many to many. All right, so the first one is 1x value to many y values. The second is 2x value to 1y value. Right? And the third, well, both of them. One to many, and you will see many going to one. Well, sorry, one is here. Okay, so those are the four types of mapping: one to many to one, many to many, and the one I showed you earlier. Which was one to one, right? One to one. Emily, are you okay there? Okay, nice. Let's continue. Capillary mappings. All right, next, a few definitions. Right? What's a function? Right? A function is a relation Right, sorry, it's a little long, but I wanted to point out this last part because there's a multiple choice that you have to know this little piece here, right? So a function of relation in which each element is mapped to exactly one, not necessarily different, but can only be mapped to one, right? Output element with no, right? With no input element being left out. So you can't have a one-to-one mapping like this. You can't have a one-to-one mapping like this and one of the input values are left out. Right? This here, this example is not a function. Okay? Not a function as the words are messed up there, right? So I got
The question is like definition of multiple choice.
no, the examples they give here. Yeah, you have to listen to that. The options they give here. The options they give you, I have to know that.
So I'm not going to repeat what you're asking.
Yeah, 40 and other 45 like 45. Then we do all the years and then we're looking at it. At most like 41. At least no, I think this year they have catch up with one another. This is happening. But then sometimes go by enough so everything big. But January yes.
Now we have one and a half. Well, choice I need to physics and math one.
Yeah, we also.
Yeah, physics and math one.
Huh?
Well, like the three definition, I thought one like that, one like that.
Right. Which of the four mappings are functions?
One-to-one.
One-to-one for sure. We will by definition. Which of the mappings are one-to-one for sure?
One-to-one, one-to-many.
One to many. Read the definition again. Each input element is mapped to exactly one.
Many-to-one.
What do you think? Many to one to do?
Yeah.
Many to one? Right? Not necessarily different. So you have to be different. Okay? So it's important you understand that the definition, right? So one line, what's the next one you all think? One-to-one for sure. One-to-one for sure is a function. Right? Azaria said many-to-one. I feel that wrong. That's wrong as Azaria. Right? Correct. Many-to-one. Right? Because they have many x values mapping to one y value, right? So the input only has one output. Although they are the same, right? Nothing wrong if they are the same. Okay, so those two mappings, they are functions. Can you guess Azaria? Azaria, why not come into class? It's just keeps wrong as well.
Yeah, so please running that right, and I'm just going to be glad about that. Well, we're not ready to do nothing. Now, we're not something.
I'll tell you.
Like kalau atas masa kerja itu nggak begini. Apa ya? Itu hasilnya.
Yeah, tell all for sure. By tomorrow, I'm just trying to get it right to go.
We are big young kids.
By the way,
We are really good.
Alright, our next question. Online, are you okay with this definition, right? Alright, one more thing I want to give you. Right, to determine. Right, to determine. To determine if the relation is a function. Right, to determine if it's a function. Right, we right, use the vertical. Right, use the vertical line test. If it's a function, right? Right, of course, in case you all don't know it, your vertical line test is where you draw a function and draw a vertical line. Right, if the line cuts once, then it is a function, right? Right, I'll just give you two quick examples here. If you were to draw this and do the vertical line test, it don't matter where you draw it, it'll only cut once, right? So this appears to be a function, right? And two, if I give you one that looks like this, and you do a vertical line test, right? This is not a function, right? Because it has two y values, one here and one here. It has two y values, right? One there and one underneath. So it's not a function, right? Thank you. I'm gonna. What's the we move next door? Right, so that's the vertical line test, right? We are focusing now, boy. Alright, ready? Right? That is create a check and see, right, if it's a function or not, right? Good. Next thing you want to look at, three things, right? We would like to take a look at injective, surjective, and bijective. Right, so we need to know those definitions. Right, some of the things that are expected to do in functions, the things that we have done in normal math, right? How to find the integral, some of the functions, all those things, right? So you're going to see questions that ask those these basic things here. All right, so before we jump to those kind of function calculation type questions, we have to understand each one of these.
What is surjective?
Yeah, surjective, injective, and bijective. Right, what does injective mean? Real short. Injective simply means one-to-one. Injective means one-to-one. Right? It simply means one-to-one, right? Every element in the domain has a unique image. All right? So one-to-one. Okay? So injective means that the function is one-to-one. How do we show one-to-one? Right? So to show injective, we have two techniques. We have technique A, horizontal line test. Right, and I'll show you just now. And B, if f of A is equal to f of B, then we should be able to get A and B being equal. All right, so I'm going to show you how to show injective. We have two techniques, right? The horizontal line test, which is the easiest, provided you can sketch it. And then we have the mathematical way. If f of E and f of B equal, then E and B should be equal. All that's saying is if you put A and B in it, you should get them being equal. It's a function. Right? So let's see what this does, right? The horizontal line test looks like this. Right? You all remember how to sketch. We did this last week, right? Right? Determine if injective. All right, good. So here's what we have the same function, but a change of the what? What a change of there. Look at it closely. We have the same function, but I changed the range. Not the range. Because our real number. Yeah, but that's not the range. What did I change?
The x is equal to
X is R and X is positive R.
oh,
Well, belongs to. What did I change? The domain. Nice. Good job, Brianna. So I changed it to me. Right. I have a little question here. How do I sketch that? We did that last week.
well,
X squared plus 1. Huh? Alright, yeah, well, how to sketch X squared plus 1? Let's go hard. What does plus one do?
Plus 200 but no.
Flip it down, right?
Right. That way is X plus 1 is typically left.
Flip it to the left.
Right.
To the right, right? But that one will get, no, okay. Flip it down. Right? Shift it up. So the graph will look like this. Right? So that is your function. How do we show that the function is, or how do we determine if it's injective? Well,
Because you want that one.
so we do the horizontal line test. And if it cuts more than once, if it cuts the function more than once, then what?
It will not subject injective.
Right? It fails the horizontal line test. Therefore, not injective. You'll see that? So for what that's saying there is that it have two x values giving you one y value. They have two x values giving you one y value. Therefore, it is not injective. All right, that is the graphical way to do it. Right? Let's say we can't sketch the graph, then we have to go to the mathematical way, right? Sketch the graph, copy it down. Let me show you the mathematical way now. Online, are you okay with the horizontal line test? Remember, the only way we could really do the horizontal line test is we have to be able to sketch, right? Somebody's.
Yeah.
Huh?
Yeah.
Two next round. Yeah. Huh? Boleh kan so kan dia jom ayam buat tentang TV tu apa right now.
Dulu tu ada tak? So, every class you can carry up in time, you have a class. I got to go like in.
Apa sebaik apa sebaik apa sebaik.
Like they didn't start down home really.
All right. Good. The mathematical way is this now. If f of a equals to f of b, we have to show that a equals to b. So we have to do some kind of maths syrup and show that a equals to b. All right. So watch it here. Watch it first. Watch it first. F of a is a squared plus 1. F of b is b squared plus 1. Carry across the 1, so it'll cancel, and you'll get a squared, b squared. What's it do now?
Square root things.
Square or square root?
Square root.
Right, so when you square root, carry across this, you will get square root of b squared. What others? Square root of b squared is what?
B squared.
B like.
Oh.
What is square root of b? Square, I mean. What is square root of 4? Something wrong.
Yeah. Try to explore. What is that for?
Anybody online? What is square root of b squared?
Plus square root of 2 squares plus minus.
Huh?
Plus or minus.
Plus and minus. Plus and minus b. Okay? So if you look there, because a is equal to plus b and A is equal to minus B, then the rule doesn't hold. Not injected.
So it will be plus minus A.
Plus some, no, we can carry across the root. Carry across the root.
You will what?
Yeah, that's what we do. Carry across the root.
Oh,
Right? So it's not injected. But if we got A equal to B, then it is injected, right? So I want you now, based on what you learned in example 1, try example 2.
there's the same thing.
Oh, all right.
No, but X and B was our positive.
Well, it is the same thing, right?
Positive, X and B was positive.
Right. Oh yeah. Try part B, but I want you to do it both methods, horizontal and
Same ground, same ground. Here's a catch.
right. Online you can message and tell me what you got.
We got it, but point out one, we could do how many of those things. Number of people. Yes, no, it's gonna be a working one. Yeah, I will get it to one. Yeah, but then it's.
Huh? All right, let's see what you got. So remember, we only want the positive real part. So the graph looks like that. Right? If you do the horizontal line test. Sorry. Yeah. If you do the horizontal line test, it will only cut once, no matter where. Right? No matter where you put the function, it will only cut once. So therefore, injected. You don't try the mathematical part as well?
Yeah. It injected.
Right? If f of a is equal to f of b, right? Then you will get a squared plus 1 is b squared plus 1. A squared is b squared, a is plus and minus b. But remember, negative b is not in the, is not, right? Negative b is not in the range. So therefore, A is equal to B and f of x is injected. Alright, so there are times when you can't really use the graph. You can't sketch, so you will have to do the test. There are other times when it's much easier. Right?
You go, you like, oh, sorry, right?
Yeah, it's called a horizontal line test. So we expect the line to be horizontal. Right, online, all good there? Kyra, Kaylin?
What?
Alright, let's go again. I showed you, what did I just show you? Injector. I'm gonna show you the injective one time. Right, subjective in short, I'm giving you the short version first. The codomain equal to the range. Once you can show the codomain equal to the range, then it's subjective. Right? What does it also state? Right, this also states that
So that's basically how one is being.
yeah, basically. Right, the set of images of the domain. All right, so when the set of images equal to the codomain, what we have is a surjective function.
So after this one, must have better than my one.
After this, we have functions to do.
This one.
Yeah, we have, we'll still have more, I'm not finishing today.
Okay.
We have functions to do, we have modulus to do, which is part of functions.
Yeah.
And then we have cubic.
I said my one.
And I think that is the module.
And after my one, 2 and 3.
Two. That's what we do the holidays, right? Straight to the holidays. And probably a little bit of vectors.
Like, one class.
Ah,
We have to select that as one class.
well, you could, but I wouldn't. I'll take two classes. Oh no, the class the holidays longer. Yeah, my
Our code is not.
Yeah, I'll do coordinate geometry. And the holidays is strings and coordinates, not vectors. Vectors is negative. Module 3, some people find it hard modules, I'll spend more time on that.
Well, it is differentiation.
That's not.
This is an city. I don't think it's anything. I didn't give you what it means.
Right, by looking at it, A is surjective or not? By looking at it there, A is surjective, yeah, no? No. Not surjective, why?
Because it's one to not one to one.
Right, because these values are not images. It must have an image, right? Every value in the codomain must be an image. Okay? So those two are not images. If I were to try to find, and I will show you this test later on, if I were to try to find an X value for 4, it doesn't exist. If I were to find an X value for 6, it doesn't exist. So by doing that, I could show that the function is not surjective. Right? So notice X values of 4 and 6 do not exist. And what about B? Surjective or not?
Yeah.
Surjective. All right, and last definition before we try a past paper. Bijective. Right, bijective is both injective and surjective. Right, that's the last definition. Now we can start. Let's see if we can apply all of this together. All right, let's determine if one of these functions here. All right, this kind of combined last week and this week here, so I kind of hope you remember. All right, so this combined what we did last week and this week, right? Hold on, that's right, so let's quickly run over the Cavich method. I now realize Cavich method. Oh, yes, sir. All right, so let's try this one here. Is a good one, 2007. All right, look at the screen there, 2007. You'll see that? Taking all along to share. All right, take a little read. It combines last week and this week, right? Let's see if we can do that. Yeah, 2007. No, what one? Very first batch should be. I'm on that.
But. Yeah.
Yeah, open. Those don't catch it, just write down what you think the coordinates will be. They gave you a shift there.
No minus two, now you think not, right? Equal to.
X plus E, should be upwards. F of X minus E should F of X minus E should come. Yeah, we know what two one and minus two downwards. Oh, so minus the mass and point to y minus. Not point to five. Y is equal to X minus two. Mass the.
It's when you see you are on the street.
No, I went up my. Going up my.
Right, so what about you see what you want? It's true, but as a minus. You did my four.
Yeah, so let's see. X minus two, what will that do?
Shift it downwards to.
Right, it will shift the entire thing downwards too. So will the X value change? No. The Y value, the X value stays the same, but the Y value will drop by 2. So the answer will be 1, 1. Okay, 1, 1. And Sarah? Right, Sarah, so what happened in here? Plus 3 means what? Shifting where? To the left, how much? 3, right? And shifting to the left 3. So will the Y value change? And the X value becomes what? Nice. Easy. Next one, 1 to 1. How we showing 2x, 3x minus 2 is 1 to 1. But the easiest technique to use. Horizontal line test or
Horizontal line test.
horizontal? Mathematical. Yeah, you can do the horizontal, right? Anyone you want. I got to do mathematical here because right?
I do not.
Show it 1 to 1. So you're supposed to get A equal to B, right? Yeah. Alright, I'll bring any more. Come. How will it show something 1 to 1? What is two techniques? Don't forget that already. What are the two techniques to show something 1 to 1? Huh? Injective, yeah. How will it show it injective? So you have to do the horizontal line test or the mathematical test, right? So you can draw it if you want, or you can just do the mathematical test. Anyone you want. Do that fast.
So we did a particular step.
F of x is f of x plus 3 is f of x minus 3. Find the value back.
I don't know.
Right, so I am going to do the mathematical method. F of x is equal to 3x minus 2. If f of a is equal to f of b, we have 3a minus 2, 3b minus 2. The 2 will cancel off. 3a is equal to 3b, divide by 3, and you'll get a equal to b. So it means that 1. Therefore, 1. That's okay? And then the last part is where we have to go back to Form 5 maths. Find f of x plus 3 and make it equal to f of x minus 3. That's Form 5 maths, right?
We've got 5 months. Yeah.
Well, let's forget it.
Yeah.
Right, so find f of x plus 3, that's Form 5 maths, right? So all we're going to do is plug in x plus 3 in there. So it's 3 by x plus 3 minus 2. Right? And then we had to find f of that. Well, I can't remember composite functions.
Oh, basically, we put f, we are putting x plus 3.
Yeah. For this part here, you plug in x plus 3. X plus 3 in there.
So basically, x.
So you're going to get f of 3x plus 9 minus 2. That's plus 7. Is equal to f of x minus 3. And do it again. 3 into 3x plus 7 minus 2 is equal to 3 into x minus 3 minus 2. So this is 9x plus 21 minus 2 is equal to 3x minus 9 minus 2. No? Let's forget about that.
And where's going on?
Solve it.
Right?
Correct?
We don't know that more very sure.
Yes, it is. We're gonna mean that's all. So it's 9x minus 3x is equal to minus 11. 21 minus 2 is 19, so that's minus 9. 6x is equal to minus 30. X is minus 5. So it's kind of just building on what you would have done in Form 5. I'll probably do back 1 or 2 of those next week to remind you.
Yeah.
Right? Composite functions. Alright, what we know that? We still have an next one to do.
So yeah,
Yeah.
no, like, really.
I answer. Do it, do online.
What? You know, you're more than this.
Huh?
They like the governance.
At least, so some of them must come July, then July, we run.
No, it never be this one.
But I come to it.
Uh,
Alright, last thing, I wanted to show you this function one to one.
Which one?
I can't show you now. This is 20, this came in 2018, I think, or 2016.
Okay, this one take now.
I want you to determine F 1-1. Again, you have to remember who last week group. If you remember, you can pop up on other views. How are we going to show that 1-1? If you want, yeah, if you want, but after
Everybody got.
yeah, learning about the oligarch. There's one way of watching. Yo. Right? We have to determine if 1-1 and on 2. Catch graph. Your really graph. Let's see if we can do the graphical method. So look back at what we did last week and see if we can do the graphical method there. Yep, go ahead, Genesis. Have fun. Carry on going, Rich.
So we can only by here. Because it's sign different.
Oh,
One is X minus one, X minus X plus one, nothing wrong with them. There is no wrong with that.
nothing wrong with that. You can only divide. Hurry up.
Yeah, but it's fine, you say it.
How we sketching that? How we sketching that? How we sketching that earlier? Huh? But chin question, no?
No, because I read on X-Men, I should have made some. What?
That's a big game, that way.
So, if we go one upwards.
So it's going one upwards then? No, 4, but then it's stretch. You can't really show that in a graph, right?
And X minus one will be.
So it's going one upwards then? 1 to the?
Right.
Anything else? But that's it.
That's it. I have to do it.
Yeah.
So we call me again.
Before that's not, that's how it's stretched. Right? But you can't really show a stretch on a graph, right? You can only show a stretch if it compares something else. What y'all think, 1-1? Would it pass in horizontal line test?
Yeah.
But I already know we didn't draw a line, those lines are asymptotes. So if I were to draw a line anywhere, a horizontal line, touch, one. So therefore it is 1 to 1, right? Right, so it passes the horizontal line step. Therefore, 1 to 1. Alright? The next part of it is to determine if it's subjective. What do you all think?
I don't think it's
If it's on to. What do you all think? Is it subjective? Is there, so here's what you ask it. Is there any y value that doesn't have x, that is marked as x value? Is there any y value that doesn't have x value?
Yeah.
Which one?
One.
Y is 1? Yes. You sure? Y is 1 on the graph?
Yeah, why one, like it's. No, where one x is equal to 1. Yeah, that's good.
Well, you find there.
I don't know.
So I think about it. Right? Next day we're gonna come on to, we're gonna look at the same thing. What y'all taking on to? Right, when y is 0, it has 1 x value. Right, when y is 0, it has 1 x value here. Alright, so I wanted to think about it if it want to, and then we'll look at a mathematical way to show it as well. Alright. So we're gonna review this, and next day we'll do some questions on wrap up function. Alright, so that's it online. Let's start out.